All right, 81.1, our job was to simplify this, and let me just clear up why it's not simplified. We've established, I think, very thoroughly that square root of the denominator is bad. Right? We've figured this out, that if we see a square root in the denominator of a fraction, it's a bad thing. If you recall, I is the square root of -1. So it's kind of in disguise, but it is one of these problems that has a radical in the denominator. So we want to fix that situation. We're going to fix this the same way we fixed it before when it was actually a square root staring us right in the face. Is we have a binomial here. If I multiply by its conjugate, this is actually referred to as the complex conjugate because it's a complex number and it's a conjugate. So therefore, complex conjugate. You know what I'm saying? Mathematicians with all this creativity coming up and with all these cool names for things. Complex numbers is conjugate, so complex conjugate here. Rule of fractions, multiply the bottom by something, multiply the top by the same thing. And everything here is binomial, so I'm putting parentheses around each binomial to show that binomial multiplication is required. Now once I've established how I'm going to go about fixing it, now I need to actually do the multiplication to fix it. The top is a basic FOIL situation going on here. So if I do first times first, 2 times 4 makes 8. If I do outside times outside, 2 times 2i makes plus 4i. Inside times inside, 3i times 4 makes plus 3i. Last times last, 3i times 2i makes positive 6i squared. Now one thing I'm noticing in problems of this variety when we're multiplying complex numbers, some of you are getting in your head that the square root of -1, that negative actually matters in the whole multiplication process here. Let the numbers be what they are based on the signs you're looking at. So a positive times a positive makes a positive. I times I makes an I squared. Okay, so go ahead and get the actual signs of everything you're supposed to get initially. And then when you go to simplify, when you see an I squared, that makes -1 times 6 makes a -6. Let the minus happen that way, naturally, not, oh, I know there's a negative on that I, so maybe I should make this negative now instead of, no, just, you get the signs you get. Everything here is positive, all our products are positive. This I squared is a -1, which changes that product to a negative at that point. On the bottom, I can FOIL that also. First times first, 4 times 4 is positive 16. Outer terms, positive 8i. Inner terms are negative 8i. That's not a coincidence, that's what's supposed to happen. So when you do your FOIL, F-O-I-L, the outside and inside products, a positive and a negative of the same objects, because that's how we created it, right? We have a minus, we change the sign positive. This product is one sign, that product's the other sign. They're the same objects being multiplied, so the outside and inside products always cancel. That's why we can shortcut the bottom digits to FL. And then again, here when I do last times last, a negative times a positive makes a negative. 2 times 2 is 4, and I times I makes I squared. Again, let the product be what it is. Let the sign be whatever it is. And then, when you get that I squared is -1. Minus 4 and -1 make a plus 4. So in each case, when you do this complex multiplication, you're going to get an I squared object every single time. The I squared just changes the sign of that term and creates a real number. And again, these guys just cancel. So the end result of the top, if I add like terms, 8 minus 6 equals 2. 4i plus 3i makes positive 7i. And 16 plus 4 makes 20. And the final step I want you to do on these problems, complex number problems, I do want them separate objects. All right? Did I make a mistake, PJ?
Yeah.
Yeah,
Plus
3i
12i.
plus 12i.
Yeah.
8 plus 4i plus 12i.
Yeah.
Oh, geez. All right. Big mistake. All right. Saw PJ over there calculating his one. Notice this product here. I think my brain turned off for a second while that 4 is there. 4 and 3 make a total of 12 there, so plus 12i, which makes this 4i and 12i make 16i. Alright, so the last thing I want you to do with complex number problems specifically is I want a real number and an imaginary number separate from each other. So instead of putting it all together like this, I want them separated. So this 2/20 plus this 16I over 20. And then of course reduce each fraction as much as is humanly possible. Both of these divide by 2, so 1/10. Both of these divide by 4, so 4/5 I. That's how I want the final answer for a complex number to be written every time. Real number plus or minus imaginary number in that order from each other.